All right, recording is in progress. Thanks everyone for joining us at SAC Interactive tonight. My name is Nolan. We run this monthly tech meetup called SAC Interactive, where we talk about all things web and mobile development. The actual technology varies from month to month. Sometimes it's JavaScript, sometimes it's SQL or whatever else. But it is always free. It is always here the third Wednesday of the month, somewhere in the 6 to 7 p.m. California time. As far as starting time goes, I'm experimenting with start times a little bit here and there. We are always looking for speakers. If you would like to give a talk on something web or mobile tech related, please contact me and we'll get you on the calendar. And we are also always looking for ideas on future sessions. So if there's a topic you'd like to see someone else present on, please drop me a message and we'll hopefully sort that out and get someone on the calendar for that too. You can reach us on sacinteractive.com. We're also as SAC Interactive on Facebook and Twitter and LinkedIn. And with that, we've got Lewis here tonight to talk about Terraform. Lewis, the floor is yours, my friend. Take it away.
Well, thank you. Thank you. First, I want to thank you for inviting me here, Nolan. And thank you for everyone here who gave up an hour of their life just to hear me nerd about Terraform. So appreciate y'all too. So this is, my name is Lewis Conley. I'm a software engineer and I actually own Cold Chain Secure. And what I do there is I build tools to help support different type of cybersecurity initiatives. And among those are building compliant infrastructures and environments using Terraform and AWS services. So that's what I'm going to talk about tonight. All right. And so I'm excited for y'all to be here. I didn't know, anybody would be interested in hearing about this, but I'm glad that I get to talk to somebody about it. So understanding GRC compliance, let's start there. So GRC, the G it stands for governance, risk management, compliance. And what the G would be, the governance, would be the frameworks, the policies for achieving organizational objectives. And this would be planning, strategic planning, developing the policies, and managing the performance of these systems. The risk management portion of it would be actually identifying the risk, assessing the risk, mitigating the risk, and finding ways to monitor the events, whether it's progressing or digressing of these risks or threats. Compliance would be adhering to the laws and regulations to avoid legal penalties and to actually build trust. So the building trust part, I would think, would be the biggest part of it, because that's what stops a lot of businesses from doing partnerships with other businesses. It's just they don't trust your ability to keep their customers' information safe. And so a lot of these over here on the right would be the most popular ones. There's a lot of compliances out there, but some of these are the most popular. So like, where can I move this? I'm blocking it. There you go. So the ISO 27001, that's the Information Security Management Standard. So that one's so important because they actually have to, any organization who gets this compliance certification actually has to show proof that they're adhering to this certification periodically. So they have to show that they actually have the ability to maintain this management system for a long period of time. Where SOC 2 is a popular one, especially in finances, where it's actually voluntary. So they don't really have to adhere to any type of continuous monitoring of their systems. But it's looked at as very high security. And you got places like healthcare information, privacy, and security. That would be your HIPAA compliance. And any company who takes cards as payments would need to adhere to the PCI DSS compliance, so payment card industry compliance. There's a few other ones like CCPA. That's actually, you can see how local they can get. This one actually just covers residents of California. And then NIST frameworks is just a guideline that companies should put together to cultivate and build a culture of cybersecurity within a company, and not just protecting certain risks, but actually creating an environment of cybersecurity. So GRC's impact on cloud infrastructure would be securing the cloud infrastructure. A lot of these companies now are taking their web applications and their websites they're trying to modernize them. So they're taking them from on-premise only to maybe a hybrid system or completely in a private cloud. So we just need to make sure that those compliances that that need to be adhered to on premises is being carried over into your actual cloud infrastructure as well. so not missing any steps. And then so compliance automation would be using tools to continuously monitor and enforce these compliance regulations. So it's not dependent on such a manual step. And then risk mitigation is just making sure that, like I said, making sure moving from an on-premise to a cloud situation that we're looking at mitigating the risk of missing some of these steps or these boxes that need to be checked during an audit while migrating your system from on-premise to a cloud situation. So why Terraform? The biggest thing for me why I got into Terraform or started studying Terraform is because it was open source, so accessibility. Terraform, when I found out about it, it seemed like just like raw materials for constructing a building, right? And so once I dug into it, I actually was using it to provision a deployment of a application I was using, but it had about 6, 7 microservices, and there was no way I was going to just keep doing that over and over, or keep doing Docker composers over and over. So I wanted to find a way to actually build an infrastructure that would deploy the system for me. And while doing this, I fell into my cybersecurity rabbit hole and said, what else could this do? And so I've seen that the automation, the scalability, the repeatability, it really made finding a way to fine tune an environment to be compliant and making it deployable would really speed up those audit systems that I've seen a lot of cybersecurity consultants go through. Sometimes they take weeks, sometimes they take months. I feel like this could streamline a lot of the processes, especially when migrating information from on-premise to the cloud. And so some of the benefits, like I said, was simplified infrastructure management. It's not hard to put hard's relatives. It's not complex to put one of these configurations together. It's you can actually make one in one main.tf file, or you can make it as complex as you would like. But the way that Terraform is set up, it uses one provider, and once you have that provider, you can build resources within that provider's parameters. And then we got consistent environments. Like I said, these could be a cookie cutter where you get a provision how you need it, and then you can stretch it across your organization and all the sectors and user groups as needed, and make any provisions in one place. So it takes a lot of the, like I said, the manual errors out of it, reducing manual errors. So, and then setting up GRC compliance with Terraform would just be automating the compliance task, and we can use Terraform scripts, like I mentioned before, the main.tf file, but we can break those into modules. We can break those into different type of playbooks if you're familiar with like Ansible. So example like this will be deploying encrypted S3 buckets, configuring identity and access management roles, setting up AWS configuration rules, and then doing continuous monitoring with CloudTrail and doing auditing and logging. So being able to log or be able to catch events with CloudTrail, we can do as much as all the events that happen across our entire account or just across one region. And then we can audit that and collect that information and save it to a storage unit like a S3 bucket. And we can do the same thing with our AWS configuration files as well. So any changes that happen to our AWS configuration file will also be logged and saved into a log bucket as well. And so the way I look at these infrastructures or these cloud services, where infrastructure as a service would be the building that we're securing or the building that we're constructing, and it just streamlines the infrastructure. It has rapid provision and it's scalable. So it's being able to build a condo over and over and over and over once you get the first one right, and you just speed it up every single time that you create one. And then if you have to make one change to one, you can provision it over all of the buildings you've already created. So it just takes away a lot of construction time. And so Terraform helps in that way by automating this infrastructure provisioning, managing the configurations for it, and then enforcing any type of compliance that's needed for this environment. And then adding on top of that would be adding your security as a service. So your security guards, your cameras, your locks on the doors, your turnabouts, your gates, everything inside that needs to be provisioned. Who's what role and what place are you allowed to be in the building, and what authorities do you have once you're in that room, in that building? All of that is the security as a service. And then on top of that would be the IT as a service, which would be provisioning digital services or delivering IT services such as your databases, your servers, your storage systems, everything that's needed to actually operate as the business itself. And like again, Terraform helps with both of these things by just automating that system, creating the security policies, making sure that they're monitoring, logging, and tracking the incident reports or the incident response events that's happening through CloudTrail and other AWS services. And then auditing the IT services, allocating resources, and continuously checking compliance with your IT as a service portion. Some case studies include like an e-commerce platform. They're always collecting people's information online, their card information. A lot of companies are using, third-party applications who are already compliant in these places like PayPal or Stripe or companies like that. So that's the importance of being compliant, is being trustworthy to people who are trusting you with their information. A lot of information is being transferred, whether it's encrypted or not encrypted, when you slide or put a card number in something. So same thing with healthcare providers when you're dealing with PII or personal identifiable information, or even electronic health records. A lot of healthcare providers need to keep information on premises, but they also need a privatized storage system, and a lot of them are moving to clouds. So that means that this PII and these electronic health records need to be encrypted in transit and encrypted at rest at all times. So that's a very, very sensitive place for compliance. And then financial services, like I said before, SOC 2 and ISO 27001. These are big compliance places in the financial services sector. And Terraform can control these compliance and policies by creating scripts like before. And then we'll just get into the live demonstration, and I think it'll get a better understanding as we move through that. So in this demonstration, we're going to go and create and I'll try to breeze through this. So I won't talk too much about actually creating these resources and what all of the properties are. All the properties in these resources are the same as you would see in the AWS console. So there's no tricks or magic or, hidden anything happening in Terraform itself. It's just pulling the actual property names from AWS console itself and just automating that system. So I won't lean too much on how to write in Terraform, but I will talk about what properties makes this environment GDPR compliant. So that's what we're building today. We're building a GDPR compliant AWS VPC environment. And what I just said was a general data protection regulation compliant environment in Amazon Web Service, using Amazon Web Services in Terraform. That's what I'm building. So we're going to make we're going to make an environment that is compliant to storing information from people who are residents of the European Union. And so that means if you are a company or organization who collects information from anybody who is a resident of the European Union, then you must be GDPR compliant to be able to do that, or to be trusted to do that. And so to be GDPR compliant, that involves data encryption, whether that be in transit or at rest, access control, with so strict rules to make, we're looking for least privilege at this point, so strict IAM roles and policies must be in place. We're looking for auditability, so enabling logging and monitoring across services. We need data residency, like we talked about before, that this data must reside in the specific compliant region. In this case, it is the European Union. Data minimization, so we just want to collect only the data that's supposed to be collected. And an incident response, so setting up mechanisms for data breach detection and notifications. And like I said before, we start with the provider. The provider is what tells everything first. So we're using AWS, and we're going to build these resources within the EU West 1 region. That this happens to be Ireland. And then this is where you need to put your credentials. My credentials are actually stored in a environment variable. So, and that profile is set as default, and that's why That's why it's set up like this. But normally it would look like this. Of course, you wouldn't hard code your credentials, and all of this would be destroyed after this this video anyway. So that's the provider. We have it set. We have our residency. We have our data residency set already. So that's one part of the compliance. Then we'll go down to network resources, and we have our VPC. This is our building. This is what we start with. This is our isolated container of where everything is going to be placed into or provisioned to. So that takes care of the isolation portion of data protection. So everything that happens here, we need to protect all of the traffic that goes into it and out of it and protect it. And then we have to make sure that everything inside of it is encrypted and only provisioned to communicate between each other in the ways that we want it to be, or want it to be set up for GDPR compliance in this case. So from there, we're going to create our subnets. And so since we want this to be compliant and make sure that we have redundancy, we're creating 2 subnets to put into the VPC. So we have our building now, we're putting 2 big rooms inside of it. So one room is going to be called main subnet, and the other one's going to be main subnet B. And we put 2 rooms in it because we're going to configure our database to be available across multiple availability zones. So we have some redundancy in our data storage. So we don't have a single place of failure in that place. So if our database goes down, we have a backup. So when you're in the building, there's 2 rooms, subnet, main subnet and subnet B. And then in one of them, we have our main database, and the other one, we have our backup database. And then, and we can see how that's set up. So we would set it up to the VPC because that's important, making sure it's connected to the right VPCs. And then in the subnet group, we will have both of those subnets IDs placed into this subnet group. And that subnet group must be part of the same VPC for that to be connected. And then we go to our internet gateway. The reason we're putting an internet gateway in here because every VPC comes with a default one. That default one allows all traffic and straight into everything that's in the VPC. So what we want to do is we want to go ahead and ignore that door and then put our own door in and direct the traffic how we want it to go. So what we did was create a internet gateway, and then we have to put a routing table together because it comes with a default, but it's the same situation. We want to control the traffic. We tie that internet gateway to this routing table, and then we have to associate what rooms can be accessed from that door. And what we did here was put a routing table association for main subnet to be able to go to the routing table. And then we did the same thing for main subnet B to be able to do that routing table as well. So now we have our traffic directed exactly how we want it to go. So now we're going to encrypt everything in here. And what we need to do there is go to Amazon's key management system and create a key. And that's what we do here. We set up the key, and this is the portion here will just be setting up the key. What I did here was put an inline policy because there were some other services that I needed to allow to encrypt as well, like the database and any login that we were doing. So we're encrypting the login, we're encrypting the databases, and we're encrypting our S3 buckets that we were creating right here. The first S3 bucket is our main bucket. It's just going to be an empty bucket, but our second bucket is going to be our log bucket where we're going to be putting all of our AWS config changes and anything from CloudTrail catches and puts it right into that bucket. And then, but we're going to encrypt that information. So all data in those buckets will be encrypted at rest. So that's encryption of the first my bucket and then encryption of the log bucket right here. Let's see. So now we have our data at rest. We have that data at rest encrypted. So now we move on to security controls, right? So let's make our security group. And so now we're restricting traffic or ingress traffic to only accept HTTPS traffic, which is secure HTTPS transactions or transmissions. And so we put that over 443. And so now we have our encryption in transit. And so we do the same thing with our secure shell at port 22. And we also make sure that we're only accepting traffic from trusted IP ranges here. So we can set those up as however your organization needs to set that part up. And same thing with here with the secure shell. And then our egress right now is set up to allow all traffic out on all protocols. But you definitely want to do the same thing here. But the difference here would be this could break a few things if you're not if you're not setting up the right IP ranges. So we're not going to do that for the demo. We're just going to leave that alone. But that's how you would set that portion up. And this is the only traffic we're letting through. So now we have our data in transit encrypted. And so we move on to our policies and creating our roles and authorities and who can do what and where, right? So our AWS IAM role, we're going to create one for our our EC2 unit. So we're going to create a web server later, but we need somebody to be able to access that, and we only want one person. So this is our least privilege coming into play here. And so here we're going to create the role. We create the role here, and then the next thing we want to do is attach it to a policy. So we create a policy for the S3 bucket. We want the EC2 role to also have abilities to connect to the S3 bucket. And that's what we do here. So we create the S3 role policy and then place that into, and then create the policy, and then we apply the role of the EC2 role to have the authority to act out on this policy. And now this EC2 role has the ability to list in this bucket, get from this bucket, and put into this bucket. And that bucket is talking about this right here, the mybucket.arn. And ARN is just your Amazon resource name. And so mybucket.arn is for, I'm not going to get into the weeds. We're going to keep it moving. But the important part about the GDPR compliance issue here would be least privilege and only allowing the example the example EC2 instance role to have access to change anything in this bucket. All right. And then we have our log bucket, and this gives access to do the same thing that we did with the EC2 role with the S3 bucket, but now this is the S3 bucket policy for the log bucket policy. And so what we did here was give permissions to CloudTrail to act on this S3 bucket, give permissions to the AWS config to act on this bucket, and then also the root user can change these policies within this bucket. Since this is an inline policy, it's going to be created within the roles. So being able to change policies, you would still need access to the roles to be able to change the policies within the roles. That's more least privilege. Let's see. And then we're going to create a profile for the web server that we're going to create to make sure that we attach this profile to the EC2 unit to make sure anything that this role has authority can do, it can do it in this EC2 unit or EC2 server. All right. And then here we are with our web server, and I'll just show you the portion of the least privilege where the IAM instance profile is tied to the example EC2 profile that we just created above. And so now only this person is provisioned, or only this role is provisioned to create or to do anything that has policies attached to it, like the S3 bucket. The EC2 instance could reach the S3 bucket. So that EC2 role needs to be able to have provisions to reach that EC2 bucket as well, or the S3 bucket as well. And that's what we have set up here. And then now we got database configuration. I created a Postgres database. Of course, you wouldn't want to put such easy passwords, first of all, and usernames, but you don't want to hard code any of that here either. But I just wanted to show you, since this is a simple demo, that the part that we want to look at here is that we're placing this into that database subnet group that we created that has a multi-zone tenancy. Excuse me. So now this shows you that it has multi-availability zones. We put that as true. And so now it has the ability to be redundant information. So we have a fallback just in case one gets corrupted or it gets shut down, DDoS attack or anything like that happens. we have one to fall back. We shut that one down and fall back. Yes is encrypted, and we're encrypting it with the KMS key that we created earlier as well. And then we applied our web security groups to this instance for to control the inbound and outbound flow of traffic to that instance, to that Postgres instance. And then we get to our logging and monitoring, and that's where we get to the CloudTrail. The CloudTrail system, what we want to look at is the fact that it's going to be writing to the log bucket, which is also encrypted. And we gave CloudTrail the abilities to use the KMS key to encrypt into that bucket. So we gave CloudTrail role the ability to make changes within the S3 bucket, as long as it with encrypted information. And then this just shows that we're tracking everything. It doesn't have to be that way, but just for this demo, just showing it that way, and includes global service events. So this is everything across the account. And then multi-region trail will be across all of your regions as well. And then enable logging here. And then we just make sure that it is writing to the log bucket. So we just give it the permissions to go ahead and write to that log bucket here. So that is the monitoring and continuous logging, continuous monitoring of events. And it's in the response. And we do the same thing here with the AWS config delivery channel. We post that information to the log bucket as well. This is a delivery channel. The CloudTrail creates a configuration recorder, which records all the changes that happen to the AWS configuration file, and then the delivery actually delivers that information to the encrypted S3 bucket. And these are just environment variables. And so quickly, it's not going to have a full cycle, but I'll just show you the usual commands you would write to deploy a Terraform file. So this one would be Terraform init. This would initialize the background database for all of the files that you want to run. It just makes sure that it's HashiCorp company. It makes sure that all of those files are present on your machine, making sure that you install Terraform pretty much. So Terraform init. And since I already did it, it shouldn't go through too long. This is a pretty long process the first time you do it, when you first initialize it, but it's already present on my computer, so it shouldn't take that long. There we go. And then after that, you will want to go do Terraform validate. And what Terraform validate does is just literally just reads the file and says, yeah, this looks about right. And then, but if something's cut off, like it's just syntax, it's just straight syntax, and that's important to understand. So Terraform validate. That's a quick, yeah, it's cool, right? But if there is errors, it will show it right there, but only syntax errors. And then I only say that because Terraform plan, this actually takes like a hot image of your credentials, actually checks out your account, but it doesn't actually deploy anything. So it's like a pump fake. It's gonna make sure that everything is working properly how it should be. Like it's gonna check this configuration based off of what you're actually trying to do in your live environment. And so since I already ran this, it should go through fine. It should say that everything you're trying to do is already done. And you see everything that it does the plan. It shows everything that's supposed to be created and what can be created. And then at the bottom, it'll show it will usually show how many things is going to be needed to be created, how many things is going to need to be destroyed, how many things are going to need to be modified. And so you'll see that more in the actual when I actually deploy it. So Terraform apply auto approve. I say auto approve because I won't go through all the approval processes. Terraform apply is all you really need, but to skip just to do the auto approve because I already know it's going to run and save some time here. That's what I'm going to put. This should go through and show that 0 things were created, 0 things were changed, 0 things were destroyed. Yep, there we go. And so from there, you can just see it here in real time, what we created. So we created our VPCs. It's two because it's always the default when you set up a VPC or set up an account or even go to a different region. We got our subnets. We have our um, everything we create, our ACL network, ACL, the security groups, everything here. So our security group here, what's this? Okay. Yeah. Our security group here is the WebSG security group. So it just shows our security group inbound rules. It shows our security group outbound rules. So our egress and our ingress rules that we created within the Terraform file itself. And then our roles that we created, for example, our AWS service config, and then the role of the EC2 instance that we created. And then here is that inline policy that we created that we attached to the EC2 role. So we got our example S3 policy. And it should look exactly how we had it set up in Terraform. There we go. Yep. So it has the ability to list to the bucket, to get from the bucket, and to put in a bucket. And then we have our S3 buckets that we created. There's actually one I created earlier. So there's a double of the my bucket. But the one that's important is this here log bucket. So you can see this has the AWS config files and then the AWS logs. And I believe this is the one that's just tracking everything that's happening. So yeah, that's CloudTrail. And everything's encrypted. And it just shows everything through the for each region that it's already collected information for. And let's see. We should have our EC2 instance that we created somewhere here. Don't be shy. There you go. There you go. And this just shows our network setup. It is set up with our VPC or our VPC. I don't think I showed you the VPC actually being created. So yes, that's the GDPR compliant VPC, and it is with the ID. I always look at the last few digits, 170. Where are we? And that is the one that we are tied to here. And then you'll just see our database that we created. That should be here as well. And also tied to our network and the subnets as well. So these are both of the subnets that's connected in this subnet group that we created. So that's the DB main subnet group, and it is in the same VPC. So we're putting everything in the same building, just encrypting it and doubling down on our data storage, just making sure that we always got a copy. And this is our CloudTrail where we're doing our logging of everything everywhere. There we go. And that's set up for our log bucket. So that's the log trail location. So everything's being sent to an encrypted bucket, so everything is safe. And then this is our AWS config. It's pretty new, but it's down here working. It's doing its thing. And those files are being sent to the S3 buckets as well. And that is it for the live demo. At this point, I am open to questions. If anybody got questions about either GRC compliance, Terraform, or AWS integration in general, I am open to hear anything.
Thank you very much, Lewis. I have a couple questions.
Okay.
The resource stuff in the Terraform file, like VPC, Internet Gateway, subnets, and all that kind of thing. How do people go about collecting that information to put it into the Terraform file? Is that auto-generated somewhere, or do I have to just go digging through my AWS infrastructure in advance and know that stuff?
Well, the easiest way, well, not the easiest way, but the most, it would be the documentation. Documentation would help the best, but the easiest way would be probably the IntelliSense that you would use and get an IDE with some good IntelliSense or find a plugin with the IntelliSense because it tells you everything that you can put in each resource.
It being what?
In the IntelliSense. So if you're, for example, And you can match that to your AWS console. So you can have a better understanding of what parameters can actually be adjusted.
So
So
can you scroll up to the top of the file, please? I think at the top will be a better example of what I'm thinking of. Um, actually, down, yeah, like right down a little bit more, please. Um,
yeah,
Subnets, sure.
okay.
Like line 62 to 66 in there. Like, how would I know the CIDR block, for example?
You wouldn't know the CIDR block because the way I figured it out was the examples I've already created in AWS itself. So I would go back and go and press create new VPC. And then once you create a new VPC, it just drops down with all the options that you would actually have in the console, but you just have to find the corresponding name within Terraform itself.
Gotcha. Okay, cool.
And
I think that
so when
helps.
you see like cedar blocks, it gives you a drop down menu of the type of cedar blocks you would have. And I just did a little research about what would be more secure as the end numbers for the cedar blocks is why I
Gotcha.
came up with the 24. But there's options like 16 and 10 or all zeros.
Gotcha. Okay. Thank you. That helps. I got two more quick questions for you. Um, what are the costs associated with using Terraform?
The costs associated are they do vary.
Okay.
The biggest ones I'm worried about while I'm playing with these configurations would be the CloudTrail, the logging and the monitoring.
Gotcha.
Although CloudTrail's monitoring is about like 0.003 cents for each event, it does right now it's set up as logging all events. So I think that would be the provisions you would look at the most is making sure that you're not collecting more information than you need.
Okay. That helps. Thank you. And then kind of related to that, one of the things people generally don't like about AWS is it's not a flat rate per month. It goes up and down based on your traffic, based on how many XYZ type of transactions are on your database or on your server or whatever the thing is. I know there are some threshold settings in AWS where I can tell it, hey, if this service I paid for goes above, I'm making up a number, $20 a month, notify me before it starts ballooning up in cost way past that. Can Terraform help with those sorts of settings too? Can I go in here and set up, say, a database and say, and if the database usage goes above X dollars per month, send me a notification of some sort?
Yes, I haven't done that myself, but it does support the CloudWatch resource as well.
Oh,
And that's when you
awesome.
would do it within the console. And I'm sure that whatever provisions that you can create from what I've gathered, I haven't ran into any roadblocks or limitations from the what I could do within the console and what I could do with Terraform.
Gotcha. Okay, cool. Thank you. That helps. I'm done. If
Absolutely.
anyone else has questions, please feel free to unmute yourself and ask away. We've got a small group tonight, so just go for it.
All ears.
I'm gonna let Mark ask first since Mark had a hard time.
I
Go
had
for
a
it,
hard
Mark.
time.
You have a hard
Um,
stop, I think is what he meant.
Hard stop.
oh, I got you. Yeah.
Yeah.
Well, Nolan sort of stole my question. Um, but I think the question would be like, would it be possible in the workflow that you showed to actually show a demo of setting up your watches on things like or would that be a separate workflow?
You
Um,
go ahead. Sorry.
no, go ahead. That's my question.
You could set it up like I was explaining that at the beginning where this is set up as just one main.tf file, and then you also I have files up here called the your state, so you could just see where the state of your actual environment is at any given time, and it just updates every single time that you change something. And so I could just add a CloudWatch resource into here and start provisioning it right in here.
Okay.
The cool thing, and I guess for me, I like decoupling, so I would definitely decouple this. But the cool thing is you don't have to because Terraform does not care.
Cool.
All you need is your provider. It only needs one main file in each folder or each module that you would create, and so all that module would need is one provider, and then that provider is talking to all of these resources in any given order. It usually, I think I actually read that it goes in alphabetical order when it
Hmm.
reads these,
Got it, got it.
but it
Okay.
does not perform sequentially.
Interesting. Okay, very cool. Have you found that ChatGPT knows anything about this stuff, or is it so rarely used that it's useless?
It's so really used. When I was learning, because what I was trying to do was create a deployment for my application. I went through hours of YouTube videos for people who just kept talking about this part and kept talking about this part, kept talking about, and so I just devised my own notes together. And then while I was trying to create, I was creating a monster before, so that was when I was using ChatGPT to try to walk me through things. That didn't help. So it was pretty much I had to train the model to even figure out what I wanted to do first. So because I guess it hasn't been done often enough, but
I figured that was the case. I mean, you had mentioned that there wasn't even YouTube stuff, so it was probably a long shot to hope that there was AI help from it. But we have you. Awesome, thank you.
absolutely.
Oh, so my question, just so I'm understanding this, you have this configuration file, and at the top you're saying the provider is AWS, and I'm giving you the keys to my AWS account, and then it's setting up every single resource from scratch if that resource didn't already exist. Is that right?
Correct.
Wow, okay. And then when you rerun it, it's just verifying whether it would set it up if it wasn't, but if it was there, it's just confirming that it is set up. It hasn't drifted.
Exactly. So if it's say I just commented this out, and that's the easiest way to destroy something. I could just comment this subnet out, and when I run the apply again, it will look at that as a resource being destroyed. But then I'll comment it back in, and then it'll recreate it the next time I run apply. And that's what these state changes files track. So you got a backup state change file, and then you got the main state change file. And so anytime you change something in a state, it checks these files to see what it's supposed to be, and then it'll try to make the changes to what your main config file is trying to do now. So that's where it does its check.
Okay. And do you keep rerunning this, or is there a way to set this up to monitor your resources?
There is a way to monitor your resources. I have a larger setup that I was actually creating for one of my applications, where now you're dealing with auto scaling and load balancing and just CloudWatch actually monitoring. I haven't used CloudWatch in the system yet, but that is something that does help monitoring first cost and resources. And so yeah, it does give that ability, and that's something that's where it would happen. It would happen in the using the AWS service, just like you would use them in the console for your auto scaling, whether it be scaling vertically or horizontally.
Okay, cool. And then stop me if this is like out of scope, but where does Terraform and Kubernetes meet
Terraform and Kubernetes.
in terms of like managing your deployment?
I would say it works just like the closest thing I would compare this to would be like creating a workflow within GitHub Actions. You know, you're creating that. So within that GitHub Actions workflow, you could put it in a Docker Compose command, which will create a Docker container that you can deploy just like using a Kubernetes setup. I'm not very familiar with Kubernetes, but that's how we use containerization with Docker and in a workflow like this.
Oh, okay. Okay. Cool. Thank you.
Absolutely.
Anyone else? Going once, going twice? All right, I think we're good. Lewis, thank you very much, man. Appreciate your time tonight. That was great. I'm going to go ahead and stop the recording. Yeah, thank you for all the information. You want to throw your contact information on the screen real quick before we turn off the recording?
Yeah, it was pretty new. So
there you go. All right. There it is. We want to check out more about his consulting firm and talk to Lewis more about Terraform and other good stuff. There you go. Thanks again very much. I'll turn off the recording. Have a good night, everybody.